afternoon everyone, welcome to the channel. In today's video I will continue with naivebayes machine learning, and this is another type. It's called Gaussian naivebayes, and this is the mostly used one than some other types that I discussed previously, like multinomial, categorical, or Bernoulli naivebayes. And in this case the algorithm assumes that the features follow a Gaussian distribution or normal distribution, which looks like a bell-shaped curve. So let's get started. Let's import required libraries at first. So let's import matplotlib. Then from sklearn import datasets. From sklearn.model selection import train test split. Sklearn dot naivebayes import Gaussian naivebayes. And finally I need to import matrix from sklearn. Okay. From matplotlib import pyplot splt. Okay. Then I need to import the dataset from sklearn's. Load sklearn's breast cancer dataset. Datasets dot load breast cancer. Okay, let's check the shape of features and targets as well. So it says 5, 16 and 30. So we have 30 features in total and 569 samples. Okay, I think I forgot to show first few samples. So this is how it looks, the 30 features. Okay, so now let's visualize a few columns. So let's note this one, mean radius, plot histogram. Okay, so this is the histogram for the first column or first feature, which says mean radius. So if you look at the distribution of this, it looks like a bell-shaped curve, but the mean is not in the center, so it is skewed to the right, but it's a normal distribution. Let's check another one. Let's say which one. How about this one, mean area? That's also same, so it is also skewed to the right. Let's check something from here. So worst radius. similar, they follow a bell curve. Let's check on more post texture. Okay, I think in this case the mean is more towards center than the previous three that we saw. So that's why this algorithm is called Gaussian-Naivebayes, because it's suitable for datasets where the features are assumed normally distributed or that can follow a bell curve. Okay, so I don't think I need this. Let's check the unique labels that we have in the target column, which is y here. So we have 0 and 1. Let's also check the value counts. Okay, so we have 357 times 1 and 0 is present to 212 times. Let's split the dataset. So xtrain, xtest, ytrain, ytest, train test split. So we provide the features, labels, and test size at 20%, train size at 80%, random state 1. Let's check the length. So we have 445 samples in the train set and 114 in the test set out of 569 after 80-20 split for train and test. Now let's apply our machine learning method, so which is Gaussian-Naivebayes. So we instantiate it, then we fit on our train set. Okay, we have fitted. Let's check the accuracy on the test set. So we'll check the accuracy on the test set. Okay, so it says 94.74%, which is good. So let's now plot the confusion matrix. So ypred gnb.predict xtest, then confusion matrix dot confusion matrix ytest ypred, then cm gnb.classes. Okay, now this dot plot cmap blue, so it's blues. 𝗕𝗿𝗏𝑥_label, which is prediction. Font width, it should be bold. Then this will be one label, this will be title. Confusion metric, and this will be ground truth. Okay, then we develop texts. 𝗕𝗿𝗏𝗀𝗐. Okay, so typing mistake here, this will be false. Okay, so this is our confusion matrix look like on the test samples. So we got 38 correct and 70 correct for 0 and 1 respectively, 4 wrong here and 2 wrong here. Let's check the 𝗕test.value counts. So you can see we have 72 ones, 70 correct, 2 wrong, and 42 zeros, 38 correct, 4 wrong. We can also represent these with categorical labels. So in that case we have to create a list here, and if you check sklearn documentation, you will see that 0 is malignant and 1 is benign. So documentation for this dataset. This is also known as breastcancerwisconsindataset. Okay, so 0 is malignant and benign. So instead of this, now this will be categorical labels. Then we can just copy this part. Now instead of 0 and 1, we can say malignant and benign. These are two types of cancers in this dataset. Let's check a few other metrics. Let's see precision. So we need to pass white test and white bread. Then we can check the recall. F1 score and checkered score. So these are the 4 scores. So we can see they are all high enough, more than 92%, all of them. So finally, let's see our classification report. So print matrix dot white test update. Okay, so these are the fellows. They also look very good. So these are very high fellows. Okay, so we get good outcomes for this particular dataset, breast cancer Wisconsin dataset, using the Gaussian Naib-Bayes machine learning algorithm, which treats that the features of a dataset follow a Gaussian distribution. And in this case, we saw that some of the columns, so we saw this column, then probably this one, and these two, they have a bell-shaped curve-like distribution. Okay, so I think that's the end of this video. Thanks for watching.